Okay, so we have a box on a plank of wood, and we lift the end of the plank of wood, and it starts to slide at an angle of 30 degrees. What's the coefficient of static friction? So we're going to work through the solution to problem 3 here. So this is exactly like the problem that we did in class. We did this activity in class. We had a block of wood held up at this. In this case, theta is 30 degrees. So I'm going to draw that there. Okay, above the horizontal. And we have a block or a box on there, and at 30 degrees is just when it starts to slide. So we're going to assume that right at that point, the sum of all the forces is 0. Okay, so that's our picture. Our free body diagram, we have the force of gravity downward. We have the normal perpendicular to the incline, so I didn't draw that very well. Let's try that again. So there's our free body and the normal. Maybe it's more up in this direction. Okay, and then we have a force of friction that's keeping it from sliding down. I'm going to fix this too, because I didn't draw this very straight down, did I? And that's more on the side. Okay, so we have to define a coordinate system. I'm going to put that right on my plane and say that that's my x direction, that's my y direction, and I want to sum the forces in each direction. So I sum the forces in the x direction, that produces my x acceleration, and I can sum the forces in the y direction, and that produces my y acceleration. Okay, so force of gravity is not in either the x or y. Normal is in the y, force of friction is in the x. So we need to break gravity into its components. It's got a component down the plane and a component in the plane, into the plane. This side is force of gravity times cosine theta, because here's theta is right in there. And this guy is force of gravity times sine theta. Okay, so back to some of the forces. In the x direction, I said positive is downward, so I'm going to have F, sum of my forces is max. I have Fg sine theta minus the force of friction is max. And then in the y direction, I know my acceleration there is 0. We have the normal minus Fg cosine theta, and that equals 0. That tells me my normal is the force of gravity times cosine theta. So I got that. Let's slide down here a little bit. Okay, so I said it's going to slide right as the acceleration is 0, right? Or just goes past 0. So we said that the 0, we get the force of gravity equals Fg sine theta equals the force of friction. This I know is mu times the normal. Okay, so we're going to divide both sides by the normal to get mu by itself, because this is our unknown. This is what we're trying to solve for. Okay, so divide both sides by the normal, and I get the coefficient of friction mu is Fg sine theta divided by the normal, and now I plug in my normal from my y equation there, and I get Fg sine theta divided by Fg cos theta. The gravities cancel out. Sine theta over cosine theta is tan theta. Okay, so my coefficient mu s is the tan of 30 degrees, which equals 0.577. Okay, done with that. Now this is a little bit confusing. In part C, this is supposed to be a box on a horizontal floor. We're given the coefficient of static friction here is 0.35. How hard would you have to push it to make it move at a constant speed? So here's our clue. Constant speed, doesn't matter what the speed is, but a constant speed means that our net force is 0. Very important. Okay, so the forces acting on this object, we have the force of gravity downward, and we have the normal upward. Now we must be pulling it to the side, right? And then there's the force of kinetic friction opposing that. And if we add all those vectors up, they should add to 0. So we'll quickly sum the forces in the y direction, where I'm saying here's my y-axis, here's x, right? We've got to define that for our vectors. And so I know my acceleration in the y direction is going to be 0. So normal minus the force of gravity equals 0. So that means my normal in this case is equal to the force of gravity. That's not always the case. Okay. Now we sum the forces in the x direction equals max, but it told me constant speed, so I know my x acceleration is 0 too. So I have the force of the pull minus the force of kinetic friction equals 0. And this is what we're trying to find, right? Because it said, how hard would you have to push? Right? So that's what we're trying to find, the pull or the push. So I know for the force to be 0, the force of my push has to be equal to the force of friction. I know that this is mu times the normal. Okay, so I'll come up here and say that force of my push is mu times the normal. And from my x equation, I know my normal is the force of gravity, which is mg. So there's my force of my push. I'll plug in my numbers now because my algebra is done. So I have 0.35 as my coefficient. I have a mass of 1 kilogram, which was something we gave you during the exam, and gravity is 9.8 meters per second squared. Okay, so that gives me the force of the push is 3.43 newtons. And we are done with problem 3.